this video, we are going to look at finding exact values of trig functions without a calculator. In order to do that, we need to recall a bunch of the stuff we remember from the unit circle. In the first part over here, we have our ratios for sine, cosine, tangent, and its reciprocals, cosecant, secant, cotangent, in terms of x and y. In the second important part here, we're going to fill this in with our different angle measures. You notice we're on the unit circle, and all the quadrantal angles are measured. And then we have in quadrant 1 the three most important angles we need to remember. The first one is our angle of 30 degrees, which in radians is pi over 6. This coordinate, as we all know, is radical 3 over 2 and 1/2. Our next reference angle is our 45-degree angle, which is going to go right about here. And that 45-degree angle has a reference angle of pi over 4 and a coordinate of root 2 over 2 for x and y. Our third reference angle of 60 degrees is going to go right here. And at 60 degrees, we know that that's pi over 3 radians with a coordinate of 1/2 radical 3 over 2. Okay. All of those very, very important to memorize. This information is all necessary in order to find our exact values very quickly. In reference to our angles, you also should be very familiar with when these angles are positive and negative. As we know in quadrant 1, all of our trig ratios are going to be positive, right? Every x is positive, every y is positive in quadrant 1. In quadrant 2, only sine and its reciprocal are positive because here x is negative, but y is positive. So all those ratios with y for sine will be positive. In quadrant 3, we have tangent, and that's positive because both x and y are negative, and when you have that ratio, it becomes out to be positive. And finally, cosine and secant in quadrant 4, since x is positive and y is negative. Last but not least, we're going to look at, for this little section, our reference angles. You need to know that a 30-degree reference angle in one rotation, right, when theta is between 0 and 360, our reference angles are generated from the fact that our 30-degree angle comes from 150 in quadrant 2, 210 in quadrant 3, and 330 in quadrant 4. Our 45-degree reference angle generated from 135 degrees in quadrant 2, 225 degrees in quadrant 3, and 315 degrees in quadrant 4. And finally, our 60-degree reference angles come from 120 degrees in quadrant 2, 240 degrees in quadrant 3, and 300 degrees in quadrant 4. The last piece of information you definitely need to be very familiar with in finding exact values are the reciprocal functions. Identities, sorry. The reciprocal identities for sine would be 1 over cosecant. And cosecant would be equivalent to 1 over sine. Cosine theta, 1 over secant, and secant theta, 1 over cosine. Finally, tangent theta, 1 over cotangent, and cotangent theta is 1 over tangent. All of this must know and memorize. You will be responsible for exact values, knowing all of this information. Okay, so let's find some exact values. When we're given an angle like 300 degrees, and we want to find the cosine, there are a couple of steps we can follow. The first step is to look at our given angle, and we're going to find our reference angle. So in one here, I'm going to follow along with these steps. Our reference angle for 300 degrees is equal to 60 degrees. Okay, the second step is we want to determine what quadrant we're in. Determining the quadrant will help us figure out positive and negative. So come back to number 1, where's 300 degrees? Well, that is in quadrant 4. Step 3, based on that quadrant and based on the ratio that you have, we want to determine if our value is positive or negative. So in 300 degrees, cosine in quadrant 4, is that positive or negative? And that answer is positive. So step 4, and finally step 4, we want to find, we're going to evaluate for our reference angle. So in step 4, we are looking for the cosine of 60 degrees. Everybody should know, based on quadrant 1, that that is equal to a half. So our answer becomes cosine 300 degrees is equal to 1/2. Let's write that over here. These steps I will write out for these couple of examples, but after this we want to get good enough at this where we don't need to do all 4 of those steps. Okay, so let's look at negative 300 degrees. Negative 300 degrees is also a reference angle of 60 degrees. However, the quadrant, though, has changed to be in quadrant 1. What we know about cosine in quadrant 1, that it is positive. So in step 4, when we evaluate cosine of 60 degrees, also being a half, it is positive in quadrant 1. So here, our cosine for negative 300 degrees is also equivalent to 1/2. Following these 4 steps, let's look at 2 radian angles. Cosine of 5 pi over 6. Again, first thing we're going to do, determine our reference angle. Our reference angle for 5 pi over 6 is pi over 6. The quadrant where 5 pi over 6 terminal side lies is quadrant 2. And we know in quadrant 2 cosine is negative, so when we evaluate the cosine of pi over 6, we are looking at root 3 over 2. But now combine the positive and negative to our cosine of pi over 6, sorry. And we will get the value for the cosine of 5 pi over 6 is equal to negative root 3 over 2. Looking at negative 5 pi over 6, we're now rotating clockwise, but our reference angle is still going to be pi over 6. Our quadrant has changed to be in quadrant 3. And in quadrant 3, cosine is also negative. So in our last step, when we evaluate cosine of pi over 6, still equal to root 3 over 2. Now that we combine both of these right here, we are going to find the value of cosine of negative pi over 6, 5 pi over 6 is equal to also negative 3 root 3 over 2. Now, have you noticed anything on our last two answers? I hope so. We're noticing that no matter what our angle is for cosine, if we take the cosine of that negative angle, our ratios come out to be the same. Positive and negative of the same angle are equivalent. Very, very, very important. And my question is, well, why does this happen? It happens because cosine is an even function. When we get to graphing, we'll go a little bit more into that. Okay, let's look at evaluating sine. Same process, same 4 steps. Our first step, find our reference angle. Reference angle for 4 pi over 3 is pi over 3. We are in quadrant 3, and sine is negative in quadrant 3. So when we evaluate sine of our reference angle pi over 3, know that that is equal to 3 over 2. So when we combine the negative and our value, getting the fact that sine of 4 pi over 3 is equal to negative root 3 over 2. What happens with the sine of a negative angle? We saw that cosine was the same. Let's see what happens with sine. In number 1, step 1, we're going to take our reference angle, again pi over 3, but this time negative 4 pi over 3 lies in quadrant 2. You know about sine in quadrant 2 is that it is positive. So the sine of pi over 3 is now equal, is equal to 3 over 2. So when we combine that with our positive, combine these two together, we end up with a sine of negative 4 pi over 3 equal to negative root 3 over 2. Sine and cosine do not behave the same. So when we look at the same angle for sine and cosine and make one positive or negative, it is not the same. So in this case, we should notice that the sine of a negative angle, sine of an angle and its negative are not the same, but when we take the sine of that negative angle, what happened to our ratio is that it became the opposite of the sine for that positive angle. Definitely worth noting. This happens because sine is an odd function. And we'll discuss more of that in another week or so. All right, the reciprocal functions also follow the same. So cosecant is going to be an odd function. Secant is going to be an even function like cosine. And tangent, believe it or not, is actually odd as well. So as a little side note, our tangent function, tangent of a negative angle is also equal to negative tangent of that angle. And same thing for cosine. So this one is just like tangent. Okay. All right. Let's look at some of our reciprocal functions and how to figure those out. Okay, secant 7 pi over 3. As we did before, our 4 steps. First thing, find our reference angle. Regardless of the function, we're looking for the reference angle. So secant of 2 pi over 3. Sorry, so get the 7 pi over there. I'm going to change this to 2 pi over 3. Okay, so our reference angle is pi over 3. Our quadrant is 2. And what do we know about secant in quadrant 2? It's the same as cosine, and that is negative for quadrant 2. So when we evaluate, we're looking at the cosine of pi over 3, which is equal to 1/2. What does that tell you about sine? It means we're going to take this. Sine and secant are reciprocals. So the reciprocal is equal to 2. So therefore, the secant of 2 pi over 3 is equal to negative 2. Let's look at another one. These get a little tricky. Cotangent. It's reciprocal to tangent. So let's first look at our reference angle. It's equal to pi over 6. Okay. Where is 7 pi over 6? That is in quadrant 3. We know cotangent is positive in quadrant 3. But we evaluate tangent of pi over 6. Tangent of pi over 6, as we know from our unit circle, is root 3 over 3. Now we look to the reciprocal. Reciprocal of root 3 over 3, it is equal to root 3. So therefore, the cotangent of 7 pi over 6 is equal to radical 3. Let's try one more. Cosecant. Cosecant of 7 pi over 4, our reference angle is going to be pi over 4. And 7 pi over 4 is in quadrant 4. Cosecant, same sign as sine, and that is negative in quadrant 4. And when we evaluate the sine of pi over 4, we get the value of root 2 over 2. Since we're looking for the reciprocal function, the reciprocal of root 2 over 2 is equal to just root 2. So using that and the negative, we determine that the cosecant of 7 pi over 4 is equal to negative root 2. All right, last but not least, 3 examples of a quick little true-false. Is it true that negative tangent of 9 pi over 4 would equal the negative tangent of 2 pi over 4? Well, if we look at this angle here, this 9 pi over 4 has a reference angle of pi over 4. This also has a reference angle of pi over 4. Since they both have the same reference angle and they're also in the same quadrant or tangent, they will be the same. So the tangent of pi over 4 is equal to 1. They will both equal then -1. So the negative of tangent 9 pi over 4 equals -1, and so does negative tangent 2 pi plus pi over 4 also equals -1. So this is true. Okay, looking at sine negative pi over 6 minus 1200 pi, we want to figure out, well, what is it coterminal to? This is coterminal to the sine of negative pi over 6. How do you know that? Well, 1200 pi is an even number of pi, so the terminal side for that ends up on the positive x-axis. So now we've rotated down to negative pi over 6, which is in quadrant 4. Our reference angle is equal to pi over 6, and this is in, I'm running out of room, and it's in quadrant 4. So when we evaluate the sine of pi over 6 in quadrant 4, it is equal to -1/2. So therefore, our sine of negative pi over 6 minus 1200 pi equals -1/2. Last but not least, to finish this up, pi over 4 plus 17 pi. 17 pi is an odd pi, so it's on the negative x-axis, and you're going pi over 4 more. So you're actually in quadrant 3. Your reference angle is pi over 4, and it is in quadrant 3. So the tangent of pi over 4 is equal to 1. Since it's in quadrant 3, it's positive, so that, and the reciprocal to 1 is also 1, then the cotangent of our angle will be the cotangent of pi over 4 plus 17 pi is equivalent to 1. Knowing our coterminal angles, where those terminal sides fall for our odd and even rotations of pi, we can find our reference angles and determine our values for our functions. Okay. This concludes our lesson. You can now complete your worksheet on finding exact values without a calculator.